Hey everybody, welcome to another Con Support video. This time it's on comparing linear functions word problems. All right, so let's go. Let's do this. It says, Erpy wants to buy towels online. There are two stores with the kind of towel she wants. The first store charges $20 per towel and a delivery charge of $25. The following equation gives the total price in dollars of an order from the second store, including delivery, as a function of the number of towels. So N is the number of towels, and then P is the price including delivery. So let's first write the equation for the first part of this. So it's the first store. And so just when you're writing the equation, the thing you're looking for here for y equals mx plus b is you're really looking for where does it start and how does it grow? So when we think about this, the fixed cost is where it starts. So wherever it starts is going to be a fixed cost, and that's not going to change. Then you're going to have a variable, whatever that variable stands for, x, right? When time changes, or in this case, number of towels changes, right? So then in this case would be towels, right? So that's our variable. We don't know how many towels we're going to have. And then there's usually some kind of rate. That's your multiplier, right? Some kind of growth rate. So I'm going to just write growth rate here. If I can scroll this up a little bit, there we go. So I'm going to write growth rate. So really the M is like how it grows, and then the B value is like where it starts. And then the result is Y, right? The output is based on all this stuff put together. All right, so in this case, it says the first store charges $20 per towel. So that's the rate, right? The rate is that they're charging you $20 for every one towel, where X is the number of towels. Okay, cool. And the delivery charge is $25. Now, whether you buy 50 things, 100 things, or 1,000 things, it's only going to cost you how much for delivery? $25. So that's a fixed cost. And then the result is the total cost. Okay, Y is the total cost. So if you wanted to like write that in there, you can think of that as Y as the total cost. All right, cool. So now we've got this equation we can compare over here. So if you wanted to use the same variables they use there, this equation would be capital P is equal to 20 times N plus 25. Okay, these are the two equivalent equations, store one, store two. It says, which store charges more per towel? Okay, well, obviously the plus 18 is the multiplier here. So that means they're charging $18 for every towel. And over here, we're charging $20 for every towel. So store two, the second store, charges less per towel, and store one charges more. So which store charges more per towel would be store one. Then it says, Upi needs 15 towels. Which store is cheaper for her? All right, so when we're thinking of which is cheaper, just plug in the value of 15. So we're just going to take this and evaluate it for when x is 15, or n is 15 in this case. So 15 times 20 is going to be 300. And so it's 300 plus 25, which is going to be a cost at the first store of $325. Okay. At the second store, you're going to be looking at a situation where you have 35 plus 18n. So for that second store option, I'll do this in blue to compare it. You're going to have P is equal to 35 plus 18n. Well, that's going to be the same as 35 plus 18 times 15, right? So we're going to have P is equal to 35 plus 18 times 15. Now 18 times 15, I'm going to just do on the calculator because I can't be bothered to do it any other way. So let's go to a little calculator here. I'm going to go 18 times 15 is equal to 270. So that's going to cost only 270 for the total towel cost. Then you have this initial delivery fee as well. So what's 270 plus 35? The total cost here is going to be 305. But the blue obviously is cheaper than the green, right? So we can see that in this case, store 2 is cheaper than store 1. All right. So it says Erpy needs 15 towels. Which store is going to be cheaper? Store 2 is going to be cheaper. And that's it. And now you go to the next question. All right, so let's scroll down here and get a clean slate. All right. It says here, Mr. and Mrs. Smith started walking home from different locations at the same time. They each walked at a constant speed. So they have a constant rate. Their slope is constant. Mr. Smith's distance in kilometers from home as a function of time in minutes is given by the following table of values. So after 14 minutes, he's 3.6. After 21, he's 2.9. After 28, he's 2.2. Okay, so basically they're saying that this is a linear function where time is x and distance is y, basically. And this is the table that represents it. The graph of Mr. Smith's distance in kilometers from home is shown as a function of time is shown below. Okay, so we can see that graph down below over here. Okay. All right, it says who walked at a greater distance to get home? And then, of course, who walked faster? So when they ask who walked at a greater distance to get home, that's just the starting value, like how far away were you from home, right? So that would be a situation where you look at the y-intercept, right? So whoever has a higher y-intercept is going to be a greater distance from home. So that's the person who's going to walk further and all to get home. And then the next question is who walked faster? That's going to be asking about the slope. Which one is a faster slope? Which is a faster rate? So let's take a look at the first table and figure out what we've got there. So what I would do is I list out the values. I'm just going to put x for time and y for distance. And I'm just going to go 14 for time and 3.6. And then we had another value of 21 and 2.9. And because they say it walked at a constant rate, we know this is going to be linear. We don't really need the third point. So now we're going to go here and say, okay, what's the change in the y direction? From 3.6 to 2.9, that's going to be a decrease of 0.7. And what's the change in the x direction? That would be an increase of 7. So what you're looking at, change in y or change in x, is going to be negative 0.7 over positive 7, which basically is going to be negative 1/10, because 0.7 times 10 is going to be 70. So you're looking at negative 1/10. All right, so the multiplier or the slope in this particular linear function is going to be negative 1/10. So we know now that we've got an equation where we have the m value. So y equals, and we know this is going to be negative 1/10 times whatever x is plus b. Okay, now I know that negative 1/10 would make that what? So what's negative 1/10 times 14? It's going to be negative 1.4. So what would you add to negative 1.4 to get to 3.6? Basically, that's going to be your y-intercept. So all we got to do there is say, all right, well, it's going to be 1.4 to get to 0, and then an additional 3.6, right? So we're going to have to add 5 to that. So we know that the equation is not going to be plus b, it's going to be plus 5. So this is now our equation for this relationship, that the slope is negative 1/10. In other words, as the minutes increase by 1, the distance is decreasing by 1/10 of a kilometer. So basically walking 1/10 of a kilometer per minute towards home. And then he started 5 miles away, or 5 kilometers away from home. Okay. When we look at the graph over here, all right, on the graph situation, you've got a starting value in distance of 4.5. Okay, so we know that the alternate situation here, the graph, if we think of the distance as y and the time as x, we can say that y is going to be equal to, and plus 4.5 is going to be part of it. And then when we look at the slope of this one, you got to find 2 points here. So I see that these 2 points are on the graph. So you want to just find 2 really clear points on the line. I see that there. So you're going down 1, 2, 3 units, and to the right 2 units. And every unit here is a half, I think. Let's see. No, it's 0.25. So if you're going down 0.25, 0.25, and 0.25, that's really 0.75 down. And over, it looks like to 5, right? So that means that if you're finding the slope of this particular relationship, you're decreasing 0.75, and that's the change in the y direction, right? 0.25, 0.25, 0.25, because you got to pay attention to the scale here. And then over here, we're, and then over here, we're going to move 2.5, 2.5, so 5 to the right. So really what you have is negative 0.75 over 5, which is, if we double top and bottom there, negative 1.5 out of 10, which is going to be, if you think about that, the same as negative 15 out of 100, which is the same as, if you think about it, is it negative 0.15, right? Just so we can compare these two. So this is negative 0.1, this is negative 0.15. So this is at a faster rate. So basically, this graph is showing that she started closer to home, and she also is, or I don't know if it's she or he, but the second person is starting closer to home and walking faster. So their equation is going to win both of these battles, I think. So let's just put that in. All right, so this is our equation for this blue line here. So now we can answer our questions. So it says here, who walked at a greater speed to get home? So let's figure out. It says Mr. Smith's distance is given by the following values, and Mrs. Smith is from the graph. Okay, yeah, so the graph is purple and the Mr. Smith is this one up here. All right, so it says, who walked at a greater distance to get home? The person who walked farther to get home is going to be Mr. Smith. Okay, this first equation starts at 5, well, this one starts at 4.5. And then it says, who walked faster? Well, Mrs. Smith is walking at 15 hundredths, and this person is walking at 10 hundredths. So Mrs. Smith is walking faster to get home. And that's the answer. All right. The next one says, Mr. Mole and Bugs Bunny started digging their way into the ground from two different locations at the same time. They each dug at a constant rate. So once again, there's a constant slope. The following equation gives Mr. Mole's altitude in meters relative to the ground as a function of time in minutes. Okay, so after a certain number of minutes, this is his altitude. Okay. Bugs Bunny's altitude in meters relative to the ground as a function of time in minutes is given by the following table of values. Okay, so we should figure out what the equation for that one would be. And then it says who dug faster. So the question of who dug faster is going to be who has the greater slope. And the question, I would say greater absolute value slope, right? It's going to be going up anyway, so it's going to be positive. And then who started at a higher altitude, okay, is going to be whoever has the higher value as an absolute value, as a y-intercept, okay? So let's go through and do this. All right, so the first thing I'm gonna do is write the equation for Bugs Bunny, because Mr. Mole, we know Mr. Mole already. Mr. Mole is gonna be A is equal to negative 0.6t minus 4, okay? So that's Mr. Mole, but we don't know Bugs Bunny yet. So Bugs' situation is something we gotta investigate. So let's do Bugs Bunny here. We know that when we got a little, let's do it with their variables just to make it fun, T and A. So T and A. And so here we go. We know that when T is 2, A is negative 1.6. When T is 9, A is negative 7.2. So in order to solve for Bugs Bunny's equation here, what we're going to have to do is figure out what his change in y over change in x is, or what his change in a over change in t is. And so what would you add to negative 1.6 to get to negative 7.2? Well, it's on the same side of the number line, so you're just going to basically go what 7.2 minus 1.6. So if you do a little 7.2 minus 1.6 action over here, we're going to borrow, you get 12, take away 6 is 6, and 6 takes away 1 is 5. So you're looking at 5.6, okay? So this is a decrease of 5.6. And from 2 to 9, it's going to be 7, right? So when you're looking at the slope here, the slope for Bugs Bunny is going to be negative 5.6 over 7, which is the same as, if you think about it, that's like 56 over 7 in terms of just division without the decimal place. So that's going to be 8, right? So it's going to be negative 0.8. And you can check it, negative 0.8 times 7 should be negative 5.6, and it is. So our multiplier is going to be negative 0.8. And then we got to figure out what our y-intercept is. So if we know that this is our multiplier, y equals negative 0.8 times whatever x is. So let's just do the variables they have there. So I'm going to change the y to the a, and we'll just kind of go from there. So a equals negative 0.8t, and then plus whatever the y-intercept is. Well, what adjustment do we have to make here? So 2 times negative 0.8 is going to be negative 1.6. That's kind of funny. Is 9 times negative 0.8 equal to negative 7.2? I think so. I think Bugs Bunny is proportional. That's kind of funny. So, I mean, it's funny with the story anyways. So let's go back and look at the story for a second. So what's funny about this one is Bugs Bunny, this is proportional, right? So Bugs Bunny is at 0. So what really you're seeing here is this is the two equations that you're comparing. This is Bugs Bunny's equation down here, and this is Mr. Mole's equation. So it says they start at different places. That's very true. Bugs Bunny starts on the surface. And I guess it makes sense. He's above the ground, and he starts digging from above the ground. So he's on the surface of the ground at 0. And Mr. Mole starts 4 feet, 4, I don't know what units this is. 4 meters below the ground. So Mr. Mole starts at 4 meters below the ground and then digs from there. So now we can talk about it here. So it says here, who dug faster? So Bugs Bunny is digging at negative 0.8 and Mr. Mole is digging at negative 0.6. So Bugs Bunny is digging faster because he has a greater absolute value. So you're basically thinking about not so much is it a greater mathematical value, right? It's a greater absolute value because how fast is he digging down? But whether you're going up or down doesn't make a difference. It's just about the distance covered, right? He's covering more distance, okay? So Bugs Bunny's digging faster. And then it says, who started at a higher altitude? Well, Bugs Bunny did because he started at 0, whereas the mole started at 4 meters below the surface. And so that's the answer. All right, let's do the next one. So this one here says, okay. Thor and Zeus strike with their hammers. The higher they raise their hammers before they strike, the louder the sound of the strike. The following equation gives the loudness of Thor's strike in decibels as a function of the height from which he strikes in centimeters. Okay, S equals 3H plus 25. The graph of the loudness of Zeus's strike in decibels as a function of the height from which he strikes in centimeters is shown below. Okay, so this is the function here. So basically, you're looking at it, you're seeing that the x-axis is the height and the y-axis is the loudness in decibels. So when you're looking at the y-intercept here, plus 25, that's the height at which he's going to strike from. Is that the height? No, what is that? The height is going to be the h, right? So it's 3 times the height he strikes from. So what's the plus 25 there? The plus 25 would be the amount of decibels when the height is 0. So basically decimals before the strike. Okay, so let's say Thor and Zeus strike with their hammers. The higher they raise their hammers before they strike, the louder the sound of the strike. The following equation gives the loudness of Thor's strike. Okay, so basically this is the base value of the strike of loudness, basically, before you even strike, I guess. This is their natural starting point. All right, so it says whose loudness increases more per additional centimeter of height? Okay, and whose strike is louder when he strikes from a height of 40 centimeters? Okay, so, all right, let's investigate this one. So the first thing we need to do is figure out what this situation would be here. So this is, I think, Thor's strike, right? So let's write Thor. So this is S equals 3H plus 25. And the two questions, one says, oh, whose loudness increases more per additional centimeter of height? That would be the slope question, right? Like, so whose slope is greater? And then this one says, whose strike is louder when he strikes from a height of 40 centimeters? So that means when H is 40, what is the corresponding S value? So let's just solve for that one. So 3 times 40 plus 25, and that's going to equal S. And so what we have there is that S is equal to 120 plus 25, or 145. So what that's telling us is that for Thor, when he has a strike from 40 centimeters, it's going to be a sound level of decibels that is 145 decibels. Okay, now let's look at the other graph we have here. Okay, so this is Zeus, I suppose. So let's do Zeus. Let's figure out what his equation is. So for Zeus here, we gotta think. It's hard to kind of see where it starts. There's not a clear value there. I mean, you can't make the assumption that you know what that is. So I see that that dot looks pretty accurate, and I see that that dot looks pretty accurate. So let's talk about the 2 points that we have on this graph. So the 2 points we have on this graph are going to be that first dot right there, which is going to be when x is 5, y is 30. So when x is 5, y is 30. And then you're going to have the next dot that's an exact location on the graph, which is right there. And that's when x is 15, y is 60. When x is 15, y is 60. So you're going to have to ask yourself, what's the equation of a line passing through those 2 points? And so the first thing you do is change in y. The change in y is plus 30. And what's the change in x? Plus 10. So that tells you that it's going to be a multiplier of 3. So S is going to be equal to 3 times whatever the height is. And then what's the y-intercept? If it's 3, then when we think about it, we know that there's going to be a value of 5 and 30. So 5 times 3 is 15, and 15 plus what value would equal 30? So 15 plus 15 is going to equal 30. So we know that this starting value here that we couldn't quite identify is going to be halfway between 0 and 30, so that makes sense, 15. That works. So this is Zeus's equation, and this is up here is Thor's equation. So in Zeus's equation, the actual rate's the same, right? They're at the same multiplier, 3 times height. So what you're really talking about here is 120 plus 15, which is only 135. So it looks like Zeus is going to lose this battle to Thor. All right, so let's go back and answer the questions here. So it says, whose loudness increases more per additional centimeter of height? And that's going to be where they tie, because their slopes are the same. And then it says, whose strike is louder when he strikes from a height of 40 centimeters? So the person who's louder is going to be Thor, okay, because he starts at a higher base value than Zeus. So that's how you do it. And hopefully that was helpful to you guys.